From our investigation with Desmos, we have figured out that this C thing that's attached to the x within the bracket tells us about the horizontal translation, left or right. This will affect the x-coordinates of where your max and min points will be. As far as your axis of the curve and the amplitude and the period, those things don't actually change. Those all are the same as y equals sine x. The d on the end is your vertical translation, up or down. Now that identifies the position of your axis of the curve. So if your axis of the curve was at y equals 0 for y equals sine x, and you slide that curve up 1, then your new axis of the curve will be at y equals 1. If you were to slide the curve down 5, then your new axis of the curve would be y equals negative 5. It also will affect the y-coordinate of the max and the min points. And to get your max and min, your max is always going to be your axis of the curve plus your amplitude. Axis of the curve plus amplitude. Your min will be the axis of the curve minus the amplitude.
And so far with all of our examples, our axis of our curve might change, but our amplitudes are always just 1 for these values or for these equations so far. State the transformations for each function and then sketch its graph. Okay, so this minus 45, it's attached to the x in the bracket, so that's your horizontal translation, 45 degrees to the right. So always think of the opposite sign of what's there. All the other key characteristics of that sine curve will be exactly the same. In the next one, we have the minus 2, but it's not attached to the x in brackets, so that's your vertical translation down 2. So then that means the equation of the axis will be at y equals negative 2. All right, the last example has both a horizontal translation and a vertical translation. It's moving 30 degrees to the left, and then it's moving up 1 unit. And because it's moving up 1 unit, we know the equation of the axis of the curve will be at y equals 1. All right, so now we're going to put this into graphs, and I'm just going to add in a new screen here. Okay, and so to begin, we're going to first start by graphing just y equals sine x. That always passes through the origin, and it has a period of 360, so it's going to be back on the axis of the curve of y equals 0 at 360, and halfway in between it's on the axis of the curve. Between the first 2 anchor points, we should be at the maximum of 1, and between the second pair of anchor points that are on the axis of the curve, we should be at the minimum of negative 1. So now I'm going to join those together to make a nice smooth curve. Don't make it like straight lines joining those together. You want to be curved because it's not going at a constant rate between the points themselves. They're not linear in between, it's curved. Okay, so there's my original y equals sine x. And from there we're going to do our transformations. So the first one we said was moving 45 degrees to the right. So I'm going to do this in blue. 45 degrees to the right means I want to move every single one of these anchor points right by 45 degrees. Now if this is 90, half of that would be 45 degrees. So this anchor point moves 45 degrees to the right. This anchor point is moving 45 degrees to the right, 45 degrees to the right, 45 degrees to the right, and so on. So that is just sliding that graph to the right by 45 degrees. So then I'm going to join those new anchor points together because that's the only transformation occurring for that particular graph. Okay, and then I'm going to extend it back this way. 40, should be at a min, 6 before this, 1, 2, 3, 4, 5, 6, so somewhere in here would be my min, so I'm heading that way. All right, so that's part A in blue. Now I had to rewrite this equation because my symbols up at the top for my recording are covering the equation. This was the moving down 2. So I'm going to take that black curve, and every single point gets slid down 2 units. So this is 1, 2. So there's my new axis of the curve at y equals 2. I'm going to go down 1, 2. So I move this point down 2, move this point back to my new axis of the curve at y equals negative 2, back to the axis, down 2 units from that minimum point, and then this one's moving down 2 from the axis of the curve. So that should look just like the
black curve just slid down by 2 units. And I can extend that so we know what the curve is going to continue on as. So this is part B. Part C has both transformations here. So let me do this one in red. I want to move it to the left by 30 and then up 1. So each one of my little tick scales here on the x-axis, that's actually 15 degrees. So 2 groups of 15 would give me 30. So here's moving it 30 to the left, and then I want to move it up 1. So that point will go here. Take this point, move it 30 to the left, and up 1. 30 to the left, up 1, 30 to the left and up 1, 30 to the left and up 1, 30 to the left, up 1. So there we are. And again, join those with a nice smooth curve. We don't want any jaggedy teeth marks like a saw. That's not how this rolls. It continues on. So this is part C. All right, so work on those anchor points for your graphs and sketching them, but always start with your sign X and then move those points, and it's fairly straightforward if you follow your transformations in order from left to right. All right, a couple more examples here to complete. Let's take a look here. All right, we need to determine the equation for this particular graph. Now, I've highlighted a max and a min and another max. So between these two maxes is one full cycle, and you can see that the amplitude or the period, I'm going to just talk period here for a minute. The period is actually 360, because if I took this x-coordinate, 405, and I subtract the x-coordinate here, because that's how long it takes to get through one cycle, that gives me my 360 degrees. So I don't have to worry about period changing at all. Now, normally, my sine curve would start here at 0, 0. At 90 degrees, it would have a max of 1, so heads up. And then at 180, it would be back on the axis of the curve, and so on. So let's see what's happened here. I have a max right here normally, and now my max seems to have shifted to the left, and let's just check the scale. If this is 90, half of that would be 45. So it looks like it's moved left 45, and it was at 1 for the max, but now it's at 3, so it's gone up 2. So my axis of the curve is here at y equals 2 instead of y equals 0. So my axis of the curve is y equals 2. The amplitude is the distance vertically between the axis of the curve and the max, or the axis of the curve and the min. So my amplitude is still 1, so that's good. So my horizontal translation is 45 to the left, and my vertical translation is up 2. So my equation then should look like y equals sine x plus 45 to move it to the left 45 degrees, and then we move the whole shebang up 2. So that is a possible equation for that curve. All right, the last part here is we're going to complete this chart by filling in what we know. So far, we have not looked at any curves that have, for this unit, or for this lesson, this particular lesson, that has an amplitude other than 1. So for all of these, they still have an amplitude of 1. And similarly, all of these curves had a period of 360 degrees for them. Still took 360 degrees to complete one cycle. So we haven't changed either of those key characteristics by moving it left or right or up or down. What did change possibly was this equation of the axis of the curve. Sine x just has y equals 0 as its axis of the curve. I'm not adding anything on top of my sine x outside of that bracket, so its axis of the curve is also y equals 0. There's no vertical translation on that one. However, I've got a plus 10 on this one. That means my axis of the curve would be at positive 10. And I've got a minus 3 on this one. It means my axis of the curve is at minus 3.
Now let's back up and look at horizontal translations. Of course, sine x has nothing added or subtracted to it, so there's no horizontal translation there. But my second one has a minus 60, so that's moved 60 degrees to the right. So remember, think the opposite sign when it's attached to the x in the brackets. 60 degrees to the right. This has nothing added to x before we closed off the sign, so that has no horizontal translation. This has a plus 15 in the brackets with the x. That's going to be 15 degrees to the left. So again, think opposite to the sign that you see. All right, now let's talk about this max and min value. Remember on the first slide I said your max comes from your axis of the curve plus your amplitude. So 0 plus 1 would be 1. Your min is your axis of the curve minus your amplitude, negative 1. 0 plus 1, 1. 0 minus 1, negative 1. 10 plus 1 is 11, and then 10 minus 1 is 9. Minus 3 plus 1 is minus 2. Minus 3 minus 1 is minus 4. All right, hopefully that all makes sense and you won't have any issues with your homework, but if you do, send me an email.